Thank you for the introduction. The title sounds very long for this time of the session, but I will try to draw your attention. Thank you all for being here. So in this presentation, we will concentrate on an issue that may become of high importance for the quality of the power supplied to the customers, especially in systems with high renewable energy penetration. It is known that wind turbines and PV power plants with inverters are sources of harmonics. What is not widely discussed is that all loads, all electronic devices connected to the system are sources of harmonics. And all these loads produce an environment which we could say it's polluted, which has there's an existing voltage harmonic distortion on the grid. And this interaction with high installed powers of RES may lead to difficult situations, difficult conditions. So what we see, what we experience with our measurements in actual field tests is that the measured currents sometimes most times are influenced by the following factors: the existing distortion of the grid, the harmonic impedance characteristics of the grid, and of course, due to the fluctuating nature of the renewables, they have different behavior depending on the operating point. This means that, okay, we have a test report, including some results in it, but in these results of harmonics, in some cases, part of these currents may be attributed to the existing grid influence. And in the end, the grid compliance assessment may become difficult, especially in cases when these values are approaching the limits or violating the limits. So at the moment, this is a big problem identified already in Germany, and there is already running a big research project called Netzharmonie, which is funded by the German state, which includes a very large, wide set of measurements on a wind turbine and solar plant on unit and plant level, and also investigate methods for the correct evaluation and summation of harmonics, which is also a critical issue, how we could go from a single unit to the power plant level. So some of these methods we are going to discuss in the next. So let me first make a very brief reference to how this compliance mechanism regarding harmonics works. So we have here the starter, the IC61 series. There's a dual curve, which the right one refers to the immunity levels of the equipment. That means they are the maximum ultimate levels that could destroy the equipment. The left curve is the area where the levels of the planning levels of the system should lie, and these are defined by the grid operator, while each unit and each plant is assigned to a lower, of course, fairly lower level, which depends on the total number of the installations on the specific node of the grid. So here, for example, in a wind farm, we measure the current typically at the low voltage or medium voltage side of the transformer of the wind turbine. Then we have to aggregate all the currents, the measured currents of the total of a wind farm, and go to the point of connection. And by considering hopefully a reliable value of the grid harmonic impedance, we estimate the voltage harmonic at each order, which is what we search for, and what is the requirement there should be that this voltage distortion should be lower than a limit. What's the status of the harmonic measurements at the moment internationally? So we have two standards. that are referring to the measurement instrumentation and setup for harmonics and power quality in general. Secondly, we have the 61421 standard, which is dedicated to wind turbines, but due to the fact that it is adapted to the changing operating point of the wind turbines, can also be applied for PV inverters, as mentioned before. Then we have the IEEE 519 standard. This standard is referred inside the CA requirement, and sometimes there is, let's say, a discussion how this can be tested. So, in fact, this standard, the measurement procedure included in this standard is the same as in 21, both deriving from the 4.7 and 4.30 standards, which are the first ones, but the evaluation procedure is slightly different. We will discuss it in the next. Finally, there is the 61 series of standards, which provide the guidance of how we can make this evaluation, this assessment of the harmonic limits. And especially for the influence of the grid, there are the recent versions of the FGW guideline, German guideline, and the new draft of IEC include special annexes with methodology for having some more close estimation of this influence. So, in brief, what is the standard harmonic measurement procedure according to IEC 21 that is followed in general? So, we measure 10-minute harmonic currents. We apply the FFT transform over 200 millisecond windows, and then due to the fact that to compensate for the spectral leakage from FFT, we have to group these harmonic amplitudes. 3 types of groupings are proposed in IEC for integer harmonics, which are the integer multiples of the fundamental, using the 2 sideband harmonics. Then we have the interharmonics, the 75 Hz or 125 Hz, etc., for 50 Hz systems, which we should consider the 30 Hz band. And finally, the higher harmonics above 2 kHz, where we have to consider a 200 Hz band. There we calculate, we concentrate all the components, the Fourier components, with a resolution of 5 Hz to one single frequency. The final step is the statistical evaluation of the results. So we, according to IEC 21, we do a 10-minute averaging, simple averaging, and we have to sort out over power and divide it into bins of 10%, and there we calculate the maximum value and the relevant EHC. The results of this are transferred to the measurement report. If we consider the IEEE 519, all steps 1 to 3 are the same, but we have some changes in the evaluation procedure. So the IEEE requires also the evaluation over 3 seconds, not only 10 minutes, and also the aggregation is not arithmetic but geometrical at this stage. And finally, it is also required to calculate not the maximum but the 95th and 99 percentiles and both current and voltage. Oh, sorry, excuse me. In brief, this table summarizes the difference between the IEC 21 and the IEEE 519 standard, including also the new changes in the CDV draft of IEC. So we have the main difference are the 3 seconds value, as I said. The IEEE requires at least 1 week of measurements, and finally the 95th percentile of the measured harmonic should be presented both in current and voltage. In the end, in order to take into account that the power, output power of the wind turbine may change, we should adopt a mixed procedure, because imagine that if we measure 1 week and we have a low wind, then it is not representative of the full harmonic emission of the wind turbine. So that's all with the existing procedure, the standard measurements that we follow for the measurement reports. What else can be done to check the harmonics? So the extra tests that can be done are divided actually in two areas, in two groups. The group on the left side of the hand can be include extra evaluations over the existing results. So we can make additional statistical analysis of the existing results and make further evaluations regarding the phase angles, which are directly derived from the FFT, and also calculate the symmetrical components. Additionally, we can go and we can plan systematic tests, further tests. The daily profiles is one very typical, which might be done by using the existing data, but the longer durations that we have, the better. So we can have an idea of the daily profile. We can make noise measurements, which means that we need to switch off the wind turbine or the PV inverter totally, maybe from the MV circuit breaker, and check the voltage harmonic distortion for the rest of the grid. Switch the neighboring loads if there are neighboring power plants or wind turbines, and see the effect. Switch on and off the filters. Check the behavior of different grid impedances. I will explain the next, and maybe measuring with an AC source, which is still has to be done on a test bed level. So calculation of phase angles is important for the identification of power flow. We are talking about finding the phase angle between voltage and current. Symmetrical components are very important in cases where we have to identify asymmetrical situations. What about the daily pattern? Here you see some measurements included on a daily basis, 24-hour, presented for the fifth harmonic order. Many days are included. In the left diagram, we present simply the time series of these harmonics. We see indeed a profile, which means that, so that means that during the morning hours there's a valley in the curves, and in the night there's an increase. That is a first indication of a grid influence, in case this is isolated from the operating point of the wind turbine. To go one step further, we perform some additional analysis and evaluated the correlation among these days using one reference. So the investigations showed that indeed the harmonics with there are harmonics that have high correlation to each other. That means that there might be coming from the grid, and some other harmonics which are clearly due to the wind turbine have very low correlation. Other investigations that can be done include the graphical investigation of the examination of the measurements. Even we can go on a 200 millisecond level and check the behavior of the harmonics, voltage and current over active power or between voltage and current. Switching of the neighboring loads, that's something that can be scheduled if possible on the test site to switch a wind turbine that is working nearby. So these are results of the real test, where in this specific situation we showed that without the neighboring wind turbine the situation is a little bit slightly improves. And this can be attributed to two main reasons. First, due to the change of the grid impedance, and secondly, due to the maybe additional harmonic emissions of the neighboring wind turbine. Noise measurements. That means switch off the wind turbine. In this case, this result presents the test where both two wind turbines were disconnected. And here we see also that the voltage harmonic distortion without the wind turbines was larger for the fifth harmonic. The same, of course, is repeated for the critical harmonic orders. Changing the grid impedances. This is let's say, somehow a new concept. We have experienced many times that a test report for the same wind turbine at different sites may have different results in terms of harmonics. So by using our LVRT test equipment, we can change drastically the series impedance between the wind turbine and the grid, And we can see two things. If there is a resonance point somehow somewhere in the low frequency range, mainly of the harmonic spectrum, and secondly, if there is any how much this change of the series impedance influences the harmonic. So in this slide, we can see in the figure on the right bottom that the harmonic current related to the inverter switching frequency is actually not affected by the connection of the series impedance, while the fifth harmonic order is clearly affected. Another method that is recently introduced is to go one step further using the measurements at the point of connection, both voltage and current harmonic measurements. If we know with a good accuracy the grid impedance and the impedance of the tested unit. In this case, if we plot the ratios, the complex ratios on the complex plane, depending on the position on this plane, we can derive some useful conclusions regarding if this specific harmonic is coming from the grid or is raised from the grid or is raised from the wind turbine. More details on that are included in the paper, so I will not go more into this. Finally, it is worth mentioning that with the grouping procedure of the IC, which focuses on the magnitudes of the harmonics, we concentrate the harmonic content, energy content on one single harmonic. But in the case of double-fed machines, the low frequency rate, we have harmonics which are slip-related. So that means they are slightly shifting. And in these graphs here, we can see that the final result with a grouping, which is included in the test certificate, might be different from the original harmonic component, and this has to be taken into account when checking grid harmonic compliance. To conclude, first of all, our proposal from our experience is that a combined approach for the harmonic analysis can be used IC21 and IEEE for compliance with CA grid code requirements. Secondly, that the harmonic results, if we see that there are some problems, we should, it is recommended to go on with further investigations and not reject, let's say, from the beginning, the unit. There is a possibility to find a way to identify which part of the harmonic is due to the grid or due to the wind turbine. Research is still ongoing. We have already some results, and there will be definitely more in the next couple of years, I would say. So this is from my side. Thank you for the attention, and feel free to ask me.
Yeah, any questions, please?
One for information and then a subsequent question. July 31st, 2017, a month back, CRC first time gave an order that let there be a third-party testing for the grid code clause, particularly to primary response. So this is information, and we are all gearing up, writing down the process and other things. Many of you must have done that also. The next question to this is, let's say if similar requirement is put in the code, and if that has to be tested for the renewables, how are the preparedness, what should be done?
So similar requirement with, if I couldn't understand exactly.
Primary response test for the conventional, all kinds of generators in the grid, to check whether they are complying with the grid code or not. And I was just extending it that, let's say if it is asked from the RE also. So you can, any of you can answer whether presently you are taking care of the primary response, whether the conventional generators are complying with or not. Are you certifying that? Is there anything thing available? And if similar thing is asked for the renewables, then how do you do it?
So I think it's not strictly related to harmonics, or?
I can answer this question. Thank you. In Germany so far, there's no direct certification of the ramp rate that is actually needed for taking or being pre-qualified in order to participate in primary reserve. There's only a testing that has to be done with the TSO. So they provide a signal, and then after this signal has been given, there must be a ramping of the pre-qualified power generator. However, this is not this is not certified by the certification office, who assess, for example, also the electric characteristics of wind turbines or solar power plants. So this is a total different measurement campaign then, and is subject to all requirements from the grid code itself. But surely it could easily be adapted in this way. So once, for example, UL or whatever of a testing institute is doing the measurement for type testing, they could easily also include such kind of tests for ramp rates. And it's basically also a test of communication infrastructure in this regard.
So here, next question.
With respect to time, this type of test is doing in commissioning test, I think so. But over the period after commissioning, is there any degradation in capabilities of LVRT, and periodically it is required to be checked or not?
Actually,
so
for me,
for
if there is any reduce of the, you mean if there is any reduce in the behavior after the years,
is there any
the coming year?
aging effect on capabilities of LVRT and HVRT and Harmonics?
An aging effect you don't see, at least for LVRT or HVRT capability. What you definitely see is, for example, when there was an outages or something, or an incident that happened. For example, there was maybe a tripping of a wind farm. That it may happen that after such kind of tripping, the initialization of the parameter at the wind turbine or even at the farm controller, that they are resetted to default mode, and that they are not parameterized accordingly to the commissioning. And this is, for example, one discussion that is ongoing in Germany as well, to have repetitive tests and repetitive assessments, because we've seen this in the practice, that this is definitely also sometimes a problem. Also for protection devices. In Germany, there's a safety guideline which says every 3 years you must check protection devices. So, but this refers to some very specific requirements. This is not in general.
It's a general.
So LVRT tests will not be repeated after a wind farm has been erected. So, and it is only done for within a type certification once. And what we do in Germany is that, based on such kind of type testing, we use the measurement data in order to validate a simulation model. And the project-specific evaluation of a wind farm will only be done by calculation and by simulation. This is our approach, how to be cost-effective, because you do once testing, spend a lot of effort in developing a simulation model, like also Eckhard Tröster just said. It's quite complex, it must be very accurate, but once you have the model, you have the potential to calculate any kind of constellation that comes to a project-specific installation.
Yeah, I would add to this that when a problem comes, the manufacturer initially confirms compliance, but when a problem comes, he has to prove that everything was set okay, as Julian mentioned. So that then starts the problem. He should have some problems then.
Okay, as I can hear coffee and tea outside, I would like to close the session. Thank you very much to all speakers. Thank you very much to my co-chair. Thank you very much for your participation and good questions, and see you in the closing session in like 15 minutes. Thank you.